So thank you for joining us again this afternoon to talk a little bit about climate change and how it's going to potentially impact the building stock of New York State. My name is Nick Rajkovich. We're hosting this webinar from the University at Buffalo, and we have Hope Forgas, who's one of our graduate research students, who's also working with me today to bring this webinar. Today's talk will focus on climate hazards of New York State. I won't go through the learning objectives in any great detail, just understand that today we really are focusing on climate hazards. As we move into some of the future courses next week on Tuesday, we'll be talking about the costs of some of these climate hazards on buildings and the built environment. And then we'll be moving into the climate resilient strategies for buildings and wrapping up 2 weeks from today, talking about energy modeling and some of its impacts on buildings as the climate begins to shift. This series of 6 webinars is supported by NYSERDA, and all of the research projects that we'll be reporting out is really done with great thanks to NYSERDA for supporting this work. We also want to thank the USGBC New York Upstate Chapter and Tracy Hall for helping us to promote this event. On Tuesday, when I presented, I neglected to mention that all of this research really, in large part, has been carried out by a number of graduate students, but especially helping with pulling this presentation together. I want to thank Lizzie Gilman, Hope Forgas, and TJ Mulligan, who really helped pull together all of the slides and to summarize the information from some of the different reports into something that's a little bit easier to digest and to talk about as part of these webinars. As we're going through today's presentation, if you'd like to follow along and find a copy of the report for yourself, it is available from our website, which is ap.buffalo.edu/adapting-buildings. On this website, as I mentioned on Tuesday, you'll find a number of different reports, but the one in particular that we're talking about today, which is about climate hazards, is this document. It's the New York State Climate Hazards Profile. So it goes into more depth and more information about some of the things that we'll be going through in terms of these climate hazards and discussing that today. A few items that we just ask you to keep in mind as we go through the presentation today. Please make sure you keep your microphone or telephone on mute during the webinar to eliminate background noise. We expect about 30 people to be on the call, so please do hold any questions you have until the end, or use the WebEx chat feature to ask questions. So Hope here today is writing out some of the questions and handing them to me to make sure we can talk about them during the presentation as we go along. Finally, this is the second of 6 webinars in a series, so the next one we're going to be talking about the cost of climate hazards is coming next Tuesday at noon. One other thing that came up on the call on Tuesday is some people said it was a little bit difficult to hear. We have kind of double-checked the audio levels and things like that. Just make sure if you can't hear through your computer, it might be better for you to log in using the phone or to put on headphones. But for sake of making sure that we kind of keep the audio levels correct, we don't want to really turn things up too much more on our end. So with that said, let's dive into looking at some of the hazards. The first one that we want to talk about is one of the big ones that has affected New York State, certainly in the last couple of years with Hurricane Sandy. The first thing that we want to talk about is hurricanes and tropical storms. And as we go through this, in the report, you'll find that it has a number of different headings for each of these hazards. If you're following along and looking at the report right now, the first thing that it has in there is the description of the hazard, what the hazard history has been in New York State, what the impact has been on buildings, and what anticipated changes we expect to see with climate change related to that hazard. So for all of the different hazards that we're going to be talking about here for the next 45 minutes or so, we'll be going through each of these different headings. So the first thing for hurricanes and tropical storms, I think it's no shock to anybody who works in the building industry that these produce very severe winds, intense precipitation, and storm surge. Although we've only had about 10 major hurricanes and tropical storm events in New York State over the last 50 years, the cost to communities has been nearly $11 billion. About $10.5 billion of that came just from Hurricane Sandy alone, and certainly had a tremendous impact on downstate New York. These extreme winds that are associated with hurricanes can certainly remove roof and wall coverings, knock homes down or tear up trees, and flooding from these can actually push structures off of their foundations or cause significant damage to any building systems that are located in an area that might flood. And one of the key terms as you go through and look at things related to flooding and related to things like storm surge is a term called the base flood elevation. One of the current concerns certainly related to climate change is that as the atmosphere warms and we have more energy in the atmosphere, it not only can produce stronger hurricanes, but also it can actually produce additional rainfall because that warmer air is actually able to hold more moisture. And as you have seen in places like Houston recently, the amount of water that can actually come from a hurricane or tropical storm event is pretty remarkable. In that case, it was on the order of 50 inches. So as we look across New York State to try to understand where this hazard hits, as one might expect, most of the hurricanes really do a significant amount of damage to the lower part of the state, to the downstate portion in the Hudson River Valley. So as these storms come off the Atlantic, they certainly impact Long Island, but then as they begin to move up, it can cause quite a bit of damage. The total costs associated with these, have caused nearly $11 billion worth of damage. But as we look at the base and down where New York City has, 98% of those total costs have actually been in that region, in that climate region down by New York City. That's not to say, though, that the hurricanes don't affect a larger part of the state. So oftentimes as we have the storms and they're moving off of the ocean and moving into the Northeast, we actually can see significant hurricane damage that starts to move up as it moves up the Hudson River Valley. So for instance, all the way up to Region 7, which is really into the Adirondack Mountains, have seen damage since 1960 associated with hurricanes. The other thing is that although it may not cause direct damage from windstorms, the rain associated with the outer rain bands that come off of hurricanes also move further west into the state. So places like climate regions 3, which is really the southern tier, 2, which is the Catskills, and then 5, which is the Saratoga region or the Capital District, have also seen damage from flooding associated with this. So it really is a significant concern. It's definitely something that we expect to continue to increase in the future. So moving from talking about hurricanes and talking about tropical storms, one of the main things that we are associated with that certainly is things like storm surge and flooding from heavy precipitation associated with the hurricanes. However, there are 8 actual other types of flooding that can cause damage to buildings, and we see all 9 of these different types of flooding in New York State. The first one, I think, which is one of the most common is riverine overbank flooding. So when we have extreme rainfall events causing a river to actually push out over its banks, this is something that happens really in all of the different regions of New York State where we have rivers. So it's not just the Susquehanna River or the Hudson River. We see it in other places in upstate New York as well. Other types of flooding, though, that happen are things like flash floods, which oftentimes are caused by having too many impervious surfaces and a high amount of rain falling in a quick period of time. Alluvial fan floods, which is something that happens as the river moves out to a larger body of water. Mud flows or debris floods, where different debris like trees or things like that can actually back up the water. Catastrophic flooding from things like dam and levee break floods, as we've all seen very recently in the last month or so in places like the Midwest. When you do have a dam or levee break, it can actually cause a tremendous damage because oftentimes those things can happen very quickly and people are not expecting those to happen. Local draining or high groundwater levels oftentimes are associated when you have a large rainfall that happens over long periods of time and the water table is actually increased. fluctuating lake levels. So where we live in Western New York, certainly being on Lake Erie, and then slightly north of us, Lake Ontario, as we saw last year, you can actually have pretty significant fluctuating lake levels where the water can actually come up several feet, although that's maybe not as common as something like riverine overbank flooding. It certainly is no less damaging. We also see ice jams, which are similar to the mud flows or debris floods, in that the ice actually backs up and causes the river to flood upstream of an ice dam. And finally, coastal flooding, which is something certainly associated with hurricanes, but also occurs in places like Buffalo and places like Watertown when you have significant wind events that actually cause the wind to pile up the water at the eastern edges of the lake. So when it's on the lake, it's actually something called a seiche, and when you see it in the ocean, we oftentimes call that coastal flooding or storm surge. So again, there are all of these different types of flooding that can potentially do damage to buildings. We have seen all of these types of flooding in New York State, and it is the only hazard that has affected all 62 counties within New York State. And it's something that before Hurricane Sandy actually came ashore was considered to be the most damaging thing that happened in New York State to New York State buildings. We've seen over the past 50 years communities near large bodies of water like the Great Lakes and the Hudson, Susquehanna River, etc., have all experienced higher than average rates of flooding. On average, we've seen a trend over time for this to continue. Part of it has to do potentially with changes in precipitation, but also part of it has to do with building more buildings in areas where they're exposed to that risk. Buildings themselves can be damaged through flooding through things like the foundation being scoured, which basically means that portions of the soil around the foundation is actually washed away. This is something that commonly happens with bridges, but when you have a building in a significant flood event, it can actually carry some of the soil away from the foundation of the building and cause it to the foundation to crack or break. Uplift from hydrostatic pressure. So when you have water that floods into a building or floods under a building, it can actually begin to lift the building up like a boat. And certainly damage that is caused from debris that's carried by floodwaters or the floodwaters themselves. And again, until Hurricane Sandy happened several years ago, this really was the primary way that buildings were being damaged in New York State, and is definitely something that we have to take into mind as we think about how the climate is changing and may impact this in the future. The really critical thing that we need to work on is finding strategies that break what is called the damage, rebuild, and damage cycle. So in New York, there are a number of buildings that have been identified by Homeland Security and by FEMA as something called a repetitive loss structure, where buildings are being rebuilt exactly the same way that they were in the past in the floodplains. In some cases, that may be unavoidable if it's a historic structure or needs to be kept in that way for historical or cultural purposes. But in many other cases where we have homes, thinking about relocating those buildings or adding adaptation strategies that break that cycle certainly make a lot of sense from an economic standpoint. As I mentioned a second ago, we've had these historical flood hazards strike really all across New York State. All of the counties of New York State have experienced at least 24 floods between 1960 and 2014. The data for this table and really data that we use to actually develop these maps comes from an organization in a University of South Carolina, which does hazards research. But you can see as you look across New York State and you look at this map, the dark blue areas actually really match where we have significant rivers, significant areas and watersheds that are draining either towards the Atlantic Ocean or up towards the Great Lakes. So places like Erie and Chautauqua County in the western part of the state can see things, not only the riverine flooding, but also things from coastal storm surge. As you move into the southern tier, places around areas like Elmira and Binghamton certainly have seen tremendous flooding coming from things like hurricanes, but also severe storms in the past. Other regions outside of, so Saratoga region, the region around the Catskill Mountains associated with the Hudson River certainly has seen flooding, and some of the areas up north have had a little bit less damage. When you take a look at what this means in terms of the historical flood hazards costs, so getting into the flood damage, right, is a function not only of how many events have actually happened, but what the value of those buildings are in that location. So when you look at the different counties around the southern tier, right, most of the flood-induced damage has actually occurred in two locations, which is really in the kind of eastern portion of the Hudson River Valley in the Capital District, and then also the Susquehanna River Valley in Region 3. And so thinking about what kinds of strategies start to work in those places is pretty important, because $1.5 billion of the $7 billion in damages that have come from flooding are really just occurring in those two locations. As we start to think about the future and what climate change might bring, because there are many different types of flooding, there are certainly different factors that go into what causes the floods. Certainly encroaching on water bodies is one reason why we potentially see increased damage, but we're also concerned about increases in the extreme precipitation that we see in the state. So currently, right now, we actually see in different locations, really in all of New York State, sees at least 5 days a year that have more than 1 inch of rainfall. But in places as you get further south in the state and you get into the Catskill Mountains, it's not coincidental that the aquifers and the watershed that drains to New York City and provides all of the water there is in one of the wettest regions of the state. This is something that is concerning about increasing in the future. And so these areas, again, towards the eastern and southern part of the state, do actually see more of those extreme rainfalls over the course of the year. As we look, though, into the future and trying to understand how over time this is potentially going to increase. So on the left on this table, you can actually see the different averages that we currently have in terms of rainfall over 1 inch per year, in the order of 6 days a year all the way up to 12 days a year in the southern part of the state. These are all expected to increase over time. So in the next decade, each one of those regions can potentially see an increase in the number of days a year that they see that extreme rainfall. But certainly as we look out 50 to 80 years in the future, there's really some significant differences in the total amount of precipitation expected in these extreme events. And that has significant impacts certainly on flooding, but also on things like our stormwater infrastructure in these cities. And because certainly some of our older post-industrial cities have systems like combined sewer systems, that can also begin to impact water quality as it goes into these larger water bodies. Although we do get a high number of events every year that have over 1 inch of rainfall, we also do tend to see have a high percentage chance of having events over 2 inches per year across New York State. So this map is slightly different. This is actually showing the percent chance of having a daily precipitation will exceed 2 inches over at least once in a year. Again, you can see in places that actually have high elevation in the state. So in Region 2, where the Catskill Mountains are, but also Region 7, where the Adirondacks Mountains are, right? These are really the areas where a lot of that heavier rainfall can actually be dumped. Some of this falls in terms of rain, but this can also happen in terms of having extreme snow events or lake effect snow events, for instance. So as you move further downstate, you're on the order of having a 75% chance of having one of these 2% rainfall events happening in any given year. And it's certainly something as we move through in the future, and looking at the regions around the Catskills, looking around the Capital District and downstate, a concern to take into account in terms of building, but also infrastructural design. And take a little sip of water. So as we look to the future, although the possibility of having these events is, there are less than one of them happening in these locations all year. By the time we start to look out to the 2080s, which may seem like a long time away, but is actually not in terms of the service life for many of our buildings. We're moving in places like Port Jervis and Rochester from having 1 or 2 days a year where you get these extreme fall events to potentially in New York City, for instance, having 5 days a year where you have more than 2 inches of rain falling in one day. Certainly, our systems currently are not designed to handle these extreme precipitation events. And so as we think about retrofitting buildings, as we think about retrofitting infrastructure, this is definitely going to be something critical to take into account in the design. And again, something like a heavy snowfall like we had here certainly in Buffalo this winter and have had in the past, those can count towards these 2-inch occurrences. So what that ends up translating to is having, more than 2 feet of snowfall in any given event at a kind of a 1 to 10 rain to snow ratio. The next hazard that we want to talk about here a little bit is severe storms. So severe storms are something that include intense precipitation events that occur over a short period of hours or even minutes. I have to say with severe storms, this is something that does not include hurricanes, does not include tropical storms. So these are spring and summertime storms. And again, these do their damage in slightly different a way than flooding. Certainly there's some overlap, but attributing damage to buildings from flooding versus the severe storms, in terms of the data, there's a slightly different designation for that. Over the past 50 years, these severe storms have impacted most of the regions of New York State, and 2/3 of these hazard events occur between May and August. So again, these are the spring and summer storms that kind of move across the country. Certainly we saw things like this happening in the southeast just in the last couple of days, but really all across New York State, this is something that can begin to cause damage to our structures. Certainly, these severe storms can cause wind damage, and with the wind damage to things like roofs or to openings in the buildings, that can turn into water damage in the buildings. And when you have a loss of power from downed electrical lines because of these storms, you can also see additional damage that's happening to buildings, or actually loss of function in the building. With temperatures projected to increase across New York State, there's a potential assumption that the intensity and frequency of these storms may increase in the future. Again, it kind of goes back to the hypothesis that with a warming climate, you have more energy in the atmosphere, and with warmer air, it's actually able to hold more precipitation. So starting to look at that data, trying to tease out what some of the trends are in terms of the attribution is still kind of an emerging science, but the expectation is there, the physics are there, and the data is expected to follow that. When you look where these hazards have moved across the state, really this is something that has impacted, again, most of the state, though downstate seems to have fewer of these severe storms than you see, for instance, in places like the northern part of the state. The places that have really the most amount of severe storm events over the last half century have been places along the Great Lakes Plain, in the southern tier, and then also around the Capital District and downstate. A lot of this has to do really with just the geography of New York State and how these types of storms move from west to east generally. In terms of the costs, a lot of the costs, again, come from a function not only of how many storms have actually happened, but also how many buildings are actually located in a particular location. So when you look at something and you want to compare a place like Rochester, it may not be that there's actually as much total damage, but there are actually more buildings in that location that have been exposed to risk. Where there's actually been a significant amount of damage, though, and should be called out as having the highest amount of damage, is actually downstate in the Catskill Mountains in Ulster County and also in Westchester County. These have actually seen more than $800 million of the total of $2.8 billion of damage in the last 50 years. A lot of that actually with these severe storms has to do with trees and other things being blown down and doing damage to buildings in some of those locations. So I now want to make a transition to a type of hazard that maybe is counterintuitive as increasing with climate change. This is also the thing where in Buffalo, New York, we really kind of win this category for the rest, among the entire country. I don't know what kind of prize you get for winning the winter storm category, but we hold on to that. So winter storms are something that can include cold temperatures, include snow, ice, high winds, blizzards, and other things like lake effect snowstorms. If you have ever lived in a lake effect region like Buffalo, Rochester, Syracuse, and Watertown, you know that there's a tremendous amount of snow that can come in a very, very short period of time, on the order of 2 or 3 inches per hour or more, causing whiteout conditions. Why is it counterintuitive? Well, as you expect the climate to warm, you might not think that there would be more winter storms associated with it. But as we begin to see things like the Great Lakes actually warm, it's something that potentially carries more moisture into these locations. And there's also some concern about how sea ice in the Arctic is changing and actually changing jet stream weather patterns in the northeastern United States. So while the trend definitely has been for warming to occur, right, and potentially over the long term to reduce the amount of snow or reduce the amount of ice that we see, as we go through that transition, it potentially is going to cause a lot more problems. Areas along the eastern shores of Lake Ontario and Lake Erie, certainly counties in the higher elevations in the Tug Hill Plateau, are much more susceptible to winter storms. And it really just has to do with the exposure to the moisture for the Great Lakes. So again, as we think about the lakes warming, right, that's able to carry more moisture into the air. And as that goes over land and cools, it drops down in really significant amounts of snow. These winter weather hazards can cause roofs to collapse from excessive snow loads, can cause power outages as trees are brought down or as the power poles themselves are brought down by things like ice, and also cause damage to overburdened heating systems when we have extreme cold weather. So places like Buffalo, for instance, in the last couple of years, in 2015 was actually the coldest January and February ever recorded in Buffalo's history. The average temperature was about, I think, 11 degrees Fahrenheit for that period of time. A lot of that has to do with, again, what was happening up in the Arctic. So although it's counterintuitive, these winter storms are potentially something that really go hand in hand with climate change. And certainly, as we see the decreasing ice cover on the Great Lakes, there's a lot of concern as a very, very clear trend on Lake Ontario and Lake Erie of losing that ice, that this may continue in the future. And also there's concern that as we see more days that hover right around freezing, we actually may see lake effect icing and ice storms associated with that. And those ice storms can be particularly damaging in terms of bringing power lines down. As we look at the historical winter storm hazards across New York State, I think it's no surprise that really anywhere to the east of one of the Great Lakes has seen a lot of winter storms in the past, on the order in places like Erie County, Jefferson, Lewis, and Oswego County, upwards of 150 winter storms during that time period that have caused damage. As you move further down in the state and you get into the warmer portions of the state around New York City, they certainly have had fewer of those storms. Although, as anybody has watched with fascination, the difficulty of removing snow from a place like New York City, smaller amounts of snow certainly can begin to cause quite a bit of damage in those locations. The highest number of places, so Regions 1, which is the Lake Erie Great Lakes Plains, Watertown region, and the area around Indian Lake and the Adirondacks are the places that have seen the most amount of these storms in the past. As we look at the costs, though, of these storms and where we have seen damage associated with it, a lot of that has been concentrated in some of the higher population areas around the Great Lakes. So in Monroe County, Erie County, Genesee County, for example, in 2014 with this November event that actually brought about 7 feet of snow to areas south of Buffalo, there were a number of roofs that were taken down or buildings that had to be evacuated, including a senior care facility. And when that actually happened, it actually caused a number of folks from that senior care facility to pass away. So, The damages associated with this, although in the long term we may see less snow, things that we have between now and that period of time when we have far less snow in New York State, it really has the potential to cause a lot of damage. Certainly places like Buffalo and Rochester are concerned about these issues and thinking about what this might mean. As the climate warms, we do expect to see fewer days under 32 degrees Fahrenheit in New York State. So all portions of the state right now currently have a certain number of days under 32. New York City, I think, is probably the luckiest in terms of having only about 70 days below freezing. As you get up into the Adirondacks, they're close to 2/3 of the year are actually have temperatures that fall below freezing. Why is this a concern? Well, a lot of what we do in terms of foundation design and a lot of in terms of the hydrology of the soil is tied to these freeze-thaw cycles. As we get into the future and we look again at how these temperatures are projected to change, right now in the next decade, we're expecting to see a drop off in terms of the total number of days we have per year that fall below freezing. But when you have those days that are right around freezing, right, that certainly can lead to ice storms, or having periods where you go through intense freeze-thaw cycles, do a lot of damage to our road infrastructure, do damage to foundations of buildings. By the time we get out to the 2080s, we really are looking at a very different climate according to the climate projections. So as you look at a place like Rochester that currently averages 133 days a year below freezing, by the time we get to the 2080s, you're potentially looking at something as low as only about 60 days a year that go below freezing. And this certainly can impact all of these existing buildings that are there, but also really change and stress things that can cause damage to buildings. So trees are not adapted to these changes, right? Pests can actually increase because of not having those very, very cold days. And certainly then they can actually be brought down by storms in their weakened state. Or more concerning, it can actually lead to wildfire and other types of events that perhaps we haven't expected as much of in a place that is wet and humid like New York State. So I think everybody has seen out in California the damage that has happened associated with the wildfires out there. But in New York State, we've been fortunate enough to not have those really significant fires. It's not something that only occurs in forested or undeveloped areas, but really along that wildland and urban interface. So although we haven't had those really huge wildfires that go across the entire state, that's not to say that we haven't had a lot of fires in the state. So we were surprised when we were doing the research to find out that rangers have actually suppressed almost 7,000 wildfires in the last 25 years, and it's burned about 68,000 acres. The buildings themselves, certainly these fires can pose a risk to buildings and human safety. Right now, though, they still tend to occur in areas with fewer structures and haven't caused the same amount of damage as some of the other hazards. But with things like having more pests, having things like fewer cold days, stressing trees, there's certainly a lot of concern that having droughts and heat waves in the future, these wildfire hazards definitely can increase and definitely can start to cause, significant fires to occur across the state. When we look at some of the wildfire hazards in the state, what's interesting enough is that actually the most amount of hazards have actually occurred out on Long Island in Suffolk County. They've actually had 4 significant wildfires out on the eastern edge of Long Island. And then other places around the Capital District and also in the Catskills in Orange County have also had some wildfires. In going through the data, though, and taking a look at it, because really most of the major fires have been suppressed in a place like the Adirondacks, and certainly there's concern about the stressing of the Adirondack tree stands, there really is the potential for an increased number of fires in those Adirondack-type locations or in the Catskill locations in the future. So it's definitely something to keep in mind from a building standpoint. Some of the historic costs, although there haven't been a large number of events around the state, we have seen a fair amount of damage. And the place that has actually received 80% of that total damage is in Port Jervis, which actually came in right around $30 million of total damage caused by wildfires since 1960. So moving out to the coast and talking about a longer-term threat to buildings, sea level rise is certainly an issue that a lot of people associate with climate change. It definitely is something that's critical for our downstate locations. Sea level rise is something that can exacerbate risks from hurricanes and tropical storms. The rate at which we're seeing sea level rise on the coastlines of New York State is ranging from about 0.8 of an inch per year to 1.5 inches per decade. Some of this sea level rise has to do with melting of ice in places like glacial ice or Antarctic ice in the oceans, but also part of it has to do with as the ocean warms, it's actually expanding and driving some of that sea level rise. Although we don't have it in this presentation, I will say that at the University at Buffalo, we have a number of people who are doing research on glaciers in places like Greenland. They really are concerned about the rate of sea level rise increasing, and what they're seeing in some of their data from the melting in these types of locations is frankly kind of very nerve-wracking, kind of terrifying, the rates of melting that they're seeing and potentially driving increased sea level rise in the future. Most of the infrastructure that we have in these locations, like levees and seawalls, have really been designed for current sea levels and may be overtopped by rising water levels or erosion in the future. And as we think about in the long term, the rising sea levels may cause permanent inundation in certain areas that are occupied by buildings and exacerbate some of the effects of storm surges. And this really can increase the risk and total costs associated with some of these coastal flooding events. In New York State, for instance, the Port Authority of New York and New Jersey is looking at what's going on with LaGuardia and what the sea level projections mean in the future. LaGuardia is really something that is pretty much at sea level, and certainly much of the Port Authority infrastructure has to by definition be at sea level. And so looking at these projections, understanding what this means, how do you keep these systems operating in the long term is a big concern across the state. While folks maybe in upstate New York might not think of sea level rise as being an important issue, in fact, as you look at things like the Great Lakes, it's unclear what the total levels of the Great Lakes will be in the long term. So it seems like perhaps it's something that's further away. That's a bit of a misconception, because with sea level rise, the Hudson River Valley is actually tidal all the way up to the Troy Dam in Albany, New York. So thinking about the areas that are subject to sea level rise, it's not just the 5 boroughs and Long Island. It's really something that extends all the way up to the state capital. And it's certainly something where a lot of our economic engine of the state is in the Hudson River Valley, something that has the potential to affect the larger economy of this entire state. When we talk about what the future sea level rise hazards are, right, in the short term, we're talking about a matter of inches. In the next decade, less than a foot is really the concern in places like New York City, and certainly at the Troy Dam on the high projection of about 9 inches. But as we start to look what happens over time, right, we are starting to talk about a bit of an acceleration, and also certainly much higher levels. So high projections for the 2050s on the order of 2 to 2.5 feet for places like the Troy Dam in New York City. And as we move to the end of the century, talking on the order of 5 feet of sea level rise. And so thinking about where we place buildings, certainly thinking about what types of storms that these buildings are be responding to, and storm surge associated with that, is really critical. Again, many of our buildings will outlive us, and looking at what these 5 feet of additional sea level rise inundates large portions of downstate New York and the Hudson River Valley. Moving into another type of hazard, one that is directly associated with warming of the climate, are heat waves. Although heat waves are something that don't necessarily cause direct damage to building, they certainly create tremendous stress on human populations, cause heat-related illness and death, pose challenges to our energy systems in buildings and more broadly, across the state. Air quality, poor air quality is associated with high temperature days. And certainly we start to see damage to infrastructure, things like buildings, and also building some bridges and other things with those high heat days. One of the things about New York State's geography and how the air tends to circulate around New York State really makes it susceptible to heat waves. Many people forget, I think, that Willis Carrier was from Syracuse, New York, and when he invented air conditioning, it really was responding to those hot, humid summers that we oftentimes have across this state. Although the heat waves do not generally cause a tremendous amount of physical damage to buildings, they certainly can stress our HVAC systems, our energy systems, so causing transformers to fail or causing other power outages. And high ozone days or high problems with other types of particulate matter are oftentimes associated with those high heat days. The average temperatures across New York are expected to increase by as much as 10 degrees Fahrenheit by the 2080s. And again, with those additional those higher temperatures, we expect to also see a higher number of heat waves and those extreme heat events. Currently, right now in New York State, really most of the state actually sees, with the exception of the Adirondacks and some of the high elevation parts of the state, days over 90. So areas around Rochester, Watertown, are expected, really have fewer of these days of year. They've rarely exceeded 90 degrees Fahrenheit. In a place like Buffalo, actually has never had a recorded day that goes over 90 degrees Fahrenheit. Goes over 100 degrees Fahrenheit. But as we move into the future and we start to talk about how climate change is potentially going to affect these heat wave events, we move from having in places like Indian Lake, which is where the Adirondacks are, less than 1 day a year over 90 degrees Fahrenheit, moving into mid-century, having something on the order of 2 to 10 days a year. This is an issue. Many of these locations don't have air conditioning or access to air conditioning. Certainly places like Buffalo actually have, many of the buildings here don't also have air conditioning. So how we begin to adapt to that, how we begin to think about these hazards is really critical. And then certainly going out into the future and thinking about places like New York City having close to 90 days a year over 90 degrees Fahrenheit, there is a significantly different climate for our buildings and for our people than what we currently have today. Current heat wave probability is really highest in downstate New York and then also in central New York. Again, I mentioned Willis Carrier. There are a lot of hot, humid days that happen in each of these locations. But in terms of those translating from a hot day into a heat wave, the current definition that's kind of used by Climate, the Climate Report and other agencies in New York State are days where you have 3 consecutive days over 90 degrees Fahrenheit. The reason this ends up being a concern is that's when the body's protective systems begin to break down. You don't have as much ability to resist the heat, and certainly you see a lot more things like hospital admissions in these types of locations. So currently in these 2 locations and in the Region 1 and also downstate, you see on the order of a 50% chance of any year having a heat wave that goes at least 3 days. As we move into the future, looking at these, the conditions in the 2020s, we have anywhere from in the Adirondacks in Region 7, less than 1 heat wave per year, to places like Rochester or New York City having 2 to 4 heat waves per year. But as we move out into the future and thinking about these locations, Region 2, which is the Catskills, Region 3, which is the Southern Tier, Region 4, which is New York City, and Region 5, which is the Capital District, all having on the order of 9 heat waves a year, really changes how we begin to think about responding to heat and how we think about keeping our buildings cool. Durations of heat waves around New York State, when they do happen, they tend to be on average on 4 days. 4 days, so all of the regions except for the Adirondacks typically see 4-day heat waves when they do happen. The Adirondacks actually have only about 3 days when they do have those events. Future duration of heat waves is also certainly a concern. So as we look where we are right now, on the order of 3 to 4 days for really the entire state. In this decade, in the 2020s, seeing something that gets on the order of 5, potentially by the end of this decade, moving into 6 days, right? And then really concerning towards the end of the century and looking at places like the Capital District, which is Region 5, having heat waves that are potentially 9 days long really puts a tremendous amount of stress on our infrastructural systems, on our energy systems, but certainly on people who may not have access to air conditioning, etc. Last but not least, and probably my favorite thing related to climate change, which sounds strange to say, but anyone who knows me knows I'm terrified of anything that has 6 or 8 legs. Pest infestation is something that we potentially are seeing more of in New York State in pests and invasive species as the climate begins to warm and as some of these species move northward. Climate change has certainly changed some of the seasonal timings of migration and budding, and with that has brought really significant changes across the northern hemisphere. So these higher temperatures really can lead to additional building damage as insects and other pests use wood or other building materials as food and shelter. And we've seen over time a shift of things like termites actually beginning to move a bit more northward in the state. Some of the people we actually talked to related to the research said that they were beginning to put termite barriers on their buildings, even though they might not be required by code, because they had seen them moving into places like the southern tier. But as we go out to the end of this century, many of the climate projections say that our climate is probably resembles something closer to what we have in the southeast right now. And certainly that brings a lot of different types of species and pests to migrate northward. In many cases, trees and our buildings themselves, not been designed around these pests. So making sure that we have things as simple as screens and windows and termite barriers and certainly things like that to use and to manage the pests in an integrated way is really critical. One of the things that was tough about finding, there's not a lot of data on damage from pests in New York State. It certainly is an area that probably needs additional research in the future. So we've gone through all of these different climate-related hazards in the last 48 minutes. I just want to thank, again, NYSERDA, USGBC New York Upstate chapter for providing support for this event today and for providing the AIA credits. I want to thank again the graduate research assistants here at the University of Buffalo and Hope, who's sitting right here, helping to make sure that this goes smoothly. If you're interested in knowing more about this topic, we certainly ask you to stop by our website, ap.buffalo.edu, and take a look at the Adapting Buildings site. And if you have any questions, we're going to open it up here in a second for people to ask questions, but you can contact me at the ap.buffalo.edu/Rajkovich. Happy to answer any questions offline that anyone has. And again, we'll be sending your attendance into the AIA for this. There's no quiz associated with it. So you should be getting that information back shortly. So I'm going to try to open this up now for people to ask questions. So one question that was typed in over the chat feature was, do you see the state setting up any efforts to increase the number of emergency responders to help deal with intensified events? Definitely climate change is something that's been incorporated into some of the all hazards documents for New York State. I can say that in our region in Western New York, there's also a lot of interest from like the Erie County Emergency Manager to beginning to deal with some of these events. So they've been partnering with us at the university to try to understand what these events might mean in the future. I think especially around issues like heat waves and some of the storms, there's concern or flooding that this could really cause a lot of significant damage in the future. So I'm hoping to see additional efforts by the state to kind of support that work. Again, if you have other questions, you can unmute yourself, but if you want to ask a question, just typing it into the chat feature also works pretty well. So a question that just came in over the chat. So really concerned about pest-related illnesses. Do you look at these issues in the built environment? So I personally am an architect, and our team here is really architecture and planning students. I think there is I agree with you, there's a significant amount of concern about these issues. I know, again, in our region, we've seen a lot of more tick-borne illnesses associated with not having cold winters to kill them off cycle to cycle. We looked a little bit as part of our research on what some of these things might cause in buildings. Fortunately, I think things like termites don't actually cause too much damage to humans other than damaging their structure. But there is concern about things like German cockroaches and other locations increasing and causing damages in buildings. It's something I would like to get into. I mentioned I'm kind of terrified of pests myself, but as of right now, I haven't done this research, though I know there have been some people downstate who are diving into this and trying to understand the health impacts. So again, if you have a question just because of the issue with feedback from somebody's phone, oh, here we go. Here's a bunch of more questions. Great. So do you foresee a trend in possibly renovating existing buildings and structures to adapt to flooding changes, and how are insurance companies going to adapt to these changes? So that's a great question. Certainly a lot of these buildings that are in places where we're going to see sea level rise is something that needs to begin to adapt. There is talk with the repetitive loss structures about making sure that we don't just build them back in exactly the same way. I think in terms of private insurance companies, a lot of them have said that they're uninterested in continuing to underwrite these projects, after they've been damaged multiple times. Whether or not places like FEMA are going to continue to underwrite that is really an issue going forward. But it is something that we're going to have to grapple with, try to understand whether or not we want to retreat or raise the buildings or protect them in other ways, because certainly this is a cause of great concern going forward. Another question that came in is, how frequently are codes being updated to address changing climate impacts? Is the frequency of code updates being increased in response? So to my knowledge, the frequency of codes being updated has not been increased, although I know that the ICC is very interested in some of the potential impacts of climate change on buildings and is looking at they and other organizations like ASHRAE, how they can begin to update codes and standards. The codes themselves are not necessarily being updated, but what can start to be updated is some of the weather information and some of the hazard data. So in the codes, it'll actually say things like you either use the data from the code, the maps, for instance, for wind damage in the codes. But one of the things that they also say is that if you have better data, if you're looking at actually what the trends are in the future, that's something that you need to take into account for design. So trying to get those maps, trying to get that data updated for New York State definitely would be something that really potentially helps, practicing architects, practicing engineers respond to future climate change. Another question that came in is about whether or not New York State has specific programs to respond to sea level rise. I do believe through Climate Smart Communities, which is a program that the DEC runs, and also programs from New York City, from the mayor's office. They do have information in terms of providing damage and providing flood mapping and trying to help point people towards resources. New York City has done a lot in recent years after Hurricane Sandy to try to update the flooding maps and to try to increase the resilience of buildings through code changes and also through voluntary standard changes. So I would encourage folks to take a look at some of those different organizations for more information. NYSERDA has also done a lot of research around the potential damage that's coming from sea level rise, and they've created a number of tools that are posted to sites like the New York State Climate Change Science Clearinghouse. So that's another place if you're interested in trying to understand how to respond to sea level rise, where you can find more information. So keep the questions coming. We have a couple more minutes here in the presentation. Happy to answer any and all questions you might have related to this topic. Well, if nobody else has any questions, I think we'll go ahead and wrap up today's presentation. Just want to thank you for joining us today. Again, if you have any questions or you want to dive into more detail on the report we talked about today, this is the website, the ap.buffalo.edu/adaptingbuildings. This is where you will find a copy of the report that we talked about today. And if you have any questions that you want to ask me offline, certainly feel free to reach out to me through the website ap.buffalo.edu/Rajkovich. It's something I'm happy to answer questions and any and all questions on this topic. So with that said, I think we'll go ahead and wrap up today's presentation. Please hope you all can join us next week on Tuesday when we'll talk a little bit about the regional impacts of climate change in New York State. And then on Thursday, start to talk about some of the strategies we can use to make buildings more resilient. So again, thanks very much and hope you have a great afternoon.